This problem was kind of a doozy. I understand why you had a question on it. It says a small company has 16 employees. The owner of the company became concerned that the employees did not know each other very well. He decided to make a picture of the friendships in the company. He placed 16 points on a sheet of paper in such a way there were no 3 collinear points. I'm going to highlight that. If you want to notice, I had that highlighted before I started this lesson. Each point represents a different employee. He then asked each employee who their friends were and connected 2 points with a line segment if they represented the friends. Part A. What is the maximum number of line segments that can be drawn between pairs among the 16 points? Well, what we're saying then, let's say every employee knows everybody else. Well, since they can't be in a line, let's make a circle, because 2 points can be in a line, but we can't have 3 points. And I think the easiest way to represent that with a circle. So we have 16 points. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I ran out of room. 15, 16. My circle is kind of a spiral. Now, what we're going to do is we're going to represent each notification or each friendship between the employees. So we'll start with our first employee. So connect the first person to the second person, the first person to the third person, and so on. Well, as you see, we go all the way around here. We're going to have 15 line segments because that first person has a line segment to everybody else except themselves. So they're going to have 15 line segments. Now, the second person, they're going to have a line segment to every other person, but they already got the first person, so we don't need to count that. That would be doubling up. So they're going to draw a line segment to everybody except themselves and the first person. So that would be 14 line segments. And then 13, and 12, and 11, and 10, and 9, 8, 7, 6, 5, 4, 3, 2, and 1. Now, there's nothing wrong with adding all of these up. That's a good way to do it. And I have no doubt that's the way most of you would do it if I gave that to you, because there's only 15, there's not that many. But since you asked, let me show you a shortcut. This is an arithmetic sequence. There's a way to add all the numbers, there's a formula actually, to add all the numbers in arithmetic sequence. And this goes back to a story from the mid-1800s. You got this teacher, she's in a one-room schoolhouse, and she's got this precocious kid who won't be quiet, he's bothering everybody else. His name was Carl. His actual name was actually Carl Gauss. And she says, Carl, come up here. I want you to take all the numbers from 1 to 100 and add them up. The idea? She wanted to keep him busy, give him some busy work. Unfortunately for the teacher, Carl came back with them up about a minute with all of them added together. How did he do it so quickly? Well, here's what he did. Math is the pattern, is looking for a pattern. So what Carl noticed, and hopefully what you'll understand here, I don't expect you to memorize this, is if he takes the first number and he adds the last number, he gets 16. If he takes the second number, 2, and he adds 14, he gets 16. And he continues to do that over and over again. Well, in other words, he has a sum of 16. How many groups does he have? Well, there are 15 numbers, aren't there? But what happens is, since there are 15 numbers, we're pairing them up, so we're going to divide that by 2. Now, it's a lot shorter. If we take 16 times 15 divided by 2, let me pull up a calculator here. (16 times 15, and we divide that by 2, we get 120. A little bit shorter way of adding all of them up. That's part A. Now let's look at part B. We're going to go through the same thing. Now, on part B, we have a circle of 10 and a circle of 6. Will that be the same number of line segments or not? Well, let's take a look here. For the circle of 10, remember, we don't start with the first verse. It'd be 9 plus 1 plus 8. Whoops. Sorry about that. 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. By the way, the formula up here, you take n plus 1 times n, and you divide by 2. So you count how many they are, you add 1, multiply it by the number of terms, and divide by 2. So on this case, there are 9 groups, so 9 plus 1 is 10. So 10 times 9 divided by 2. Well, 10 divided by 2 is 5. 5 times 9 is 45. Now let's do the same thing for 6. That'll be 1 plus 2 plus 3 plus 4 plus 5. We stop at 5. I should have done 5 plus 4 plus 3 plus 2 plus 1. So we're going to say 6 times 5 divided by 2. 6 times 5 is 30. 30 divided by 2 is 15. So the total number of handshakes for those two groups together is a lot less, isn't it? 60. Half of what we had, isn't it? That was kind of a fun, interesting problem. We'll have to throw those at you once in a while. Make your brain connect those neurons. It's always nice to work on a problem that's hard, and if you can't figure out a hard problem, then we need to ask for some help to get some help of where we need to go. And that I would expect that in this question.